channel Math with Nazia. In this video, we are going to learn about Euclid's division lemma. I have already explained how to find the H.C.F of two numbers using Euclid's division lemma method in my previous video. You can refer that and the link is given below in the description. So let's see the first example of today. If the H.C.F of 65 and 117 can be written as 65m minus 117, find the value of m. So here, as you could see, we have to first find the HCF of 65 and 117, and that answer is written in the form of 65m minus 117. Then we will find the value of m. So we will split the question. So first let's find the HCF of 65 and 117. So we have to do the division and we have to write the steps. So first let's do the division method. Simultaneously we will be writing the steps also. So the first point is we have to see the smaller number. The smaller number is 65. So I will write 65 outside. Then we will get as 117, which will be written inside. So I am going to divide 117 with 65. So 117 divided by 65, it divides one time, 65. Then we have to subtract. This is as usual the long division method. So when you subtract, you get 52. So this is our first step. So let's write our first step, which is since 117 is greater than 65, we will divide 117 with 65. So when we divide these two, what is our quotient? What quotient did we get here? Our quotient is 1 and our remainder is, right, 52. So by Euclid's division lemma, that is EDL, I've just written the short form, you can write it the whole form. By Euclid's division lemma, we will write the dividend first. I think you all remember in the previous video I've thought if dividend equals divisor times quotient plus remainder. So this is very important. This is the method of Euclid's division lemma. So what was our dividend? It is 117 equals divisor is 65 times the quotient, which is 1 plus 52. So when we divide this, we get, when we solve the 65 times 1 plus 52, we get 117. So this is our first step. Now what we will do, now since the remainder is not 0, so second step we will write, since remainder is not equal to 0, we are again going to divide the 65 and 52. So 65 will be divided with 52. Now this 65, which was a divisor, will become a dividend. The remainder will become our divisor. So now let's do that. So 65 will be written here. So 52, one time is 52. Let's subtract it again. So we get 13. Then we'll write the steps first. By our quotient is 1. Our remainder is 13. So by Euclid's division lemma, we get, first we will write our dividend, which is, right. So our dividend is 65 equals 52 times 1 plus 13. So we will write the Euclid's division lemma. Now we are going to again divide it because our remainder is still not 0. So our third step would be, since the remainder is not equal to 0, we will divide 52 with 13. 52 divided by 13, that will be our next step. So we will divide 52 here. So 13 times how much is 52? 4. So 13 times 4 is 52 and now the remainder is 0. So here we have got the quotient as 4 and the remainder as 0. So once we get the remainder 0, we will stop with that. So is it clear till this? Now the next step is, now since we have got the remainder 0, and let's see what is the HCF of these two. So HCF of 65 and 117 is equal to, right, it's 13. So 13 is our HCF. Now let's see the second part which is given, that is 65m minus 117. So HCF is written in the form of 65m minus 117 equals 13. So we have got our HCF is 13. Now this is given. Now let's find the value of m. So 65m, pause, 65m equals 13 plus 117. So 65m equals 130. So m equals 130 divided by 65. So m equals 2. So the value of m is 2. So isn't it easy? We will just follow the Euclid's division lemma step by step. Then the answer which we have got, the HCF is 13. We will apply that and then find the value of m. So now let's see the second example for today. So our second example for today is prove that n square plus n is divisible by 2 for any positive integer n. So they have given prove that n square plus n is divisible by 2 for any positive integer n. So now let's start solving this question. So before I solve, let me tell you that this question was being asked in 2019 paper, and the previous question was also asked in 2019 paper. So these are very important questions, and these are very easy questions. So let's start solving it. So first, what has been given? We have to prove that n square plus n is divisible by 2 for any positive integer. So we need a positive integer and it has to be divisible by 2. So let's take n in the form. N can be in the form of 2m or 2m plus 1. We can take two cases. Either it can be 2m or 2m plus 1. So let's take case 1, which is case A, where n equals 2m. So when n equals 2m, what happens? So we have to find n square plus n. So n square plus n equals 2m the whole square plus 2m. So 2m the whole square will become 4m square plus 2m. So I'm just going to solve this. Now since 2m is common in these two, I'll take out 2m and we can write it as 2m plus 1. Now let me take r equals m times 2m plus 1. So in place of this whole number, I'm going to put it as r. So this is equal to 2r. So now we can clearly tell that this is divisible by 2. 2r is exactly divisible by 2. So therefore n square plus n is exactly divisible by 2. So since it's exactly divisible by 2, it is a positive integer also, and it is exactly divisible by 2. Now let's take the second case, case B, where n equals 2m plus 1. So I'm going to take n as 2m plus 1. So let's write n square plus n equals, in place of n we will write 2m plus 1. So 2m plus 1 the whole square, and plus in place of n again 2m plus 1. So now in these two I'm going to take 2m plus 1 as common. So here what we'll have, 2m plus 1 which is remaining, and then again another plus 1 because this has come out. So here we can write this as 2m plus 1 and 2m plus 2. And now as you could see, there is 2 common in these two. So I will write it as 2 times of 2m plus 1 and m plus 1. So is it easy now to write like this? Now, so this is a long number. So instead of this, I will write s equals 2m plus 1 and m plus 1. So instead of this whole part, I will write it as s. So this is 2s. So as we could clearly see, 2s is exactly divisible by 2. So therefore, n square plus n is also divisible by 2. So we can tell it as n square plus 1 is divisible by 2 for any type of positive integers. So is it clear? We just need to put n as 2m and 2m plus 1. So if you have any queries regarding these type of questions, you can comment down in the comment section. And for more tips and tricks, do like and subscribe to my channel. Thank you.